Now what if we were asked if which of the following series converges conditionally? This actually has nothing to do with the ratio or root test, although we could do the ratio and root test, and only if the limits for both of them are equal to 1 could it be conditionally convergent, because the other two will give you either divergence or absolute convergence. So you could do that as a test. But for right now, let's see how we can test for conditional convergence. Well, let's first do absolute convergence to eliminate those. We can say if we do the absolute value of the first one, then we are just going to get the sum of n equals 0 to infinity of 1 over n squared, which converges by the p-test. So this converges absolutely, and since it converges absolutely, it doesn't converge conditionally. So 1's not an option. For 2, also, let's look at the series from n equals 2 to infinity of n over natural log of n. Well, let's take the limit as n goes to infinity of n over natural log of n, which if we use L'Hopital's rule, because we'll get infinity over infinity, we get 1 over n, limit as n goes to infinity, which is equal to the limit as n goes to infinity of n, which is clearly infinity, which doesn't go to 0, so this is going to diverge by the divergence test. So the last one that we can look at for conditional convergence is 3, and hopefully that's it. So we can see that it doesn't converge absolutely because it would be the series of 1 over n, which is the harmonic series, and that diverges. So does it fit the conditions of conditional convergence? Well, it's alternating, and the limit of the Bn value of 1 over n does go to infinity, does go to 0, and Bn plus 1 is clearly always less than Bn, because that's saying 1 over Bn is 1 over n plus 1 is less than 1 over n, which is, in other words, saying n is less than n plus 1. So clearly this is true. So clearly 3 fits all the conditions of the alternating series test and doesn't converge absolutely. So therefore, this series here is the one that converges conditionally, and it is the only one.